we want to solve this first order differential equation by separating the variables. So you just go ahead and pause the video and work it out. Alright, what did you get when you solved it? Let us see what's going to happen. Separating the variables. On the left you have y's and numbers if they're there, dy equal. On the right you have x and numbers if they're there, dx. Although I'm not seeing any numbers right now. Now, suppose you have two y's here. Factorize the right hand side. You have x dy by dx equals y outside the bracket 1 plus x. Okay, you have a number now, 1. But anyway, you divide both sides by y and you multiply. Well, no, you divide by x as well. Alright, so that's what you're going to do. If you divide both sides by y, you have over y over y. So you have x over y dy by dx equals y 1 plus x over y. But guess what happened now? Y will cancel y. So you only have 1 plus x over here. Then what happens here? Okay. What you have here? You have x. So you divide by x now. So divide by x. You put x here. X cancels. You divide by x and you have this. See that? So you're going to have 1 over y here. Let me erase it and rewrite it. 1 divided by y equals 1 plus x divided by x. Multiply across by dx. So you have dx. Dx will cancel dx, right? And this dx. So since dx cancel dx, you have dy alone here. It's 1 over y dy equals 1 plus x over x dx. Alright. So you're going to integrate 1 over y dy equals the integral of 1 plus x over x dx. Let's rewrite this right hand side here. You have integral of 1 over y dy equals the integral of, this would be 1 divided by x plus x divided by x dx. Well then x divided by x is 1. So let me erase this and put 1. Alright, so that's what we have. Seems like we're ready to integrate now. The integral of 1 divided by y dy, as you remember, is ln y equals, we're not going to write any plus c here until we reach over to the right hand side. This would be ln x plus x, and then we write our constant of integration plus c. Alright, so you see that. But the thing is, let's see if we can rewrite it and make it neater. Alright? You would be okay with this, you know. But let's put it in a neater form. So put you subtract both sides. Ln x from both sides. You'll have ln y minus ln x equals x plus c. Remember the rules of indices. Ln y minus ln x is the same as ln y over x, okay, equal x plus c. What do we do now? You know that from the laws of indices, if you say e to the ln something, say a, it will be equal to a. E raised to the power of ln of a number. To just give you the number. The e to the power of and the ln would cancel each other, leaving the number undisturbed. So e to the ln y over x equals, you have to e to the this as well, e to the x plus c. So y over x is equal to e to the x plus c. But remember the laws of indices. If you say e to the x plus c, is the same as e to the x times e to the c. But e to the c is just another number. So if you say let e to the c equals a, some other constants, and you have y over x is equal to a e to the c. So multiplying everything by x now, you can say y is equal to a x e to the c. Alright. So a x e. Oh, it's not e to the c. We got rid of the e to the c and make it a already. It's e to the x I should have. See it here? E to the x. Mistake. So let me just do this to the c and let it make it look like x. So you have y over x equal a e to the x. So y is equal to a x e to the x. Alright, that looks like it. But as I said before, you will have ln y minus ln x equal x plus c. That's the solution. It's just that I want it to look a bit neater. Right? It can look neater like this. Alright? Alright, so that's it for now. I'll see you in the next video.